transformations. We're going to be talking about changing shapes in a coordinate plane, whether it's being something that we slide, something you rotate, something you flip. That's going to be kind of the focal point of this. We're going to kind of come up with ways that we can look at things and the way they write the mathematical stuff for it. But really today, our big focus is going to be on what we call translations. And what we're going to ask ourselves is, how can you translate a figure in a coordinate plane? Now this is really pretty simple. Okay, this is really pretty simple today. If you can kind of think of this word translations as like a sliding of something. So you can slide something up or down or left or right. But you're not going to turn anything. You're not going to flip anything. So just think of stuff today as sliding stuff. That's all you really need to think of today. Okay, so if you hear the word translation, what one word do I want you to replace it with? Can I help us think what that means? Sliding it around, okay? So goal is to meet that question today. We're going to perform some translations. I'll show you what performing compositions mean, and then we'll look at some real-life problems that involve this stuff. But really, guys, this section is a lot about some of the terminology that comes with it, but really pretty easy. Guys, if you're moving left or right, are you making change on the x-axis or y-axis? Left and right. Which axis is the left and right? X, right? If you're making a vertical change, are you changing y values or x values? Y values. Okay, so I think you'll understand most of this when we go through the vocab. So the first thing I want to hit on here is the following. What's a vector besides a villain in Despicable Me? Vector is what?
It's like something of magnitude. It's on.
Excellent, Bryce.
Those do teach us something.
Yeah. Did you guys, you probably talked about vectors in science a little bit, haven't you? Okay. Where have you had exposure to vectors at before? Anywhere? Okay, well, let's just draw this. A vector is simply this. That's simply a vector, okay? It's basically a ray in a way, okay? It's a ray. It's what we do is we draw it in a coordinate plane, and it's represented from one point to another, and they put an arrow at the end of this, okay? So now the second one, it says the initial point right here. If I would label this vector maybe, I don't know, maybe A, and put a B out here at the end where the arrow was. The initial point, what do you think the initial point is in this vector, A or B? A is the initial point. So A is the initial point. Okay, how many of you guys have ever watched the Terminator movies before? Okay, what's the Terminator assigned to do? Go around and end people's lives, right? So what do you think point terminal or terminal point means?
End line.
It's the end of the line, right? I like that, end of the line. Okay, so terminal point means it's the ending point. So which point in this right here is going to be my terminal point? B. B is my terminal point. B is the terminal point. So if I say, hey, here's a vector, it's vector AB, you understand the initial point is really the starting point, A. And then B is the terminal point. Okay? All right. Okay, so here is we go to this idea of what we call horizontal component. Let's see, horizontal, is that left and right or up and down? Left to right. Horizontal component is simply the horizontal change from a starting point of a vector to the ending point. It's basically how far left or right do I move. So basically, if I was going from A to B in this one here, I would move a certain distance right to get to B, wouldn't I? Okay, so I'm just going to write down, it's just the change on which axis, X or Y. So it's a change in X. So what do you think vertical component's going to be then? It's the change in Y. It's a change in Y. Okay, very good so far. Slide this up a bit. All right. Everybody with me on the terms so far to this point? Okay, so the next one right here talks about component form. And component form is going to be a form of a vector that combines the horizontal and vertical components, okay? It's just basically going to be a situation where you say, well, here's a vector. If I drew this up here from start to finish, let's say that the distance going this way was maybe 6, and maybe the distance going this way was 4. You would write that component form of a vector as follows. You're going to put something like this right here. Okay, we're talking about a vector right here, AB in this right here, okay? And the component form of that is just simply the following. What was the change in your x? What was the horizontal component, guys? What was your vertical component? So we say that this is just simply, and they don't put parentheses, they make like these little arrows. You would call this 6, 4. Okay, so the component form of your vector AB is just simply how far did you change left or right, and how far did you move up or down. And you always lead from the starting point to the ending point. So if the starting point you went left, if you went left from the starting point, is that going to be a positive or negative horizontal change? Negative. And if you move down, is that going to be a positive or negative vertical change? Be negative. You bet, guys. Okay. All right. So this whole idea is about transformation. Specifically, we're going to talk translations in this chapter. But a transformation is kind of the whole broad group of the stuff that we're going to talk about this chapter. Transformation. The thing you really need to know is a function that moves or changes a figure in some way to produce a new figure. Basically, you need to understand transformation simply means to change the figure. Examples of change would be to slide something, left or right. Another example of change would be to rotate something. And we'll look at that stuff as we progress through the chapter. Another example would be to reflect something, left to right. Okay? But all you need to understand is that transformation is a change or some kind of a movement of an original figure to a new one. Okay, so the whole chapter is going to be about transformations. All right? Okay, you're going to hear this term, image. An image is a figure that results from a transformation of a geometric figure. Okay? I always like to tell kids this. An image is labeled with stuff like this. I'm just going to draw a triangle. You do the same thing. And I'm going to put up here A prime, like this. Okay, an image is always labeled with some kind of a prime. It's like an A and then an apostrophe right there. The image is always like the ending figure. Okay? It's like, what did you end up with? So guys, if an image is something you end up with, what do you think a pre-image is? The shape or whatever you start with. Okay? Pre-image is simply the original figure before a transformation. It's the shape you start with. And if I had the triangle right here, this would be point A right here. Okay? I'll always know that a figure is an image if they have these little apostrophes by the vertex of each label, the vertex I should say. Anything that has an apostrophe, we call this A prime. Okay? Anything without the primes is the original figure. Anything with the primes in the labels will be an image to what we started with. Okay? All right, guys, the word translation, and this is what we're going to focus on. This is a specific transformation that we're going to focus on today. Translation is a transformation that moves every point of a figure the same distance in the same direction. Okay? All you need to know is that this is some kind of slide movement. It's a slide movement. You're either moving left, right, up and down, or a combination of those directions. You can move left and up. You can move left and down. You can move right and up. You can move right and down. And it's really pretty easy. Okay? All right. Vocab-wise, have you got down at least everything so far? I don't expect you to have everything memorized just yet, but make sure that you can apply the terminology to the examples that we look at here in a second. So far, so good?
Yeah.
All right, let's look at the second page here, a couple more. And then we'll look at some examples. Oh, that didn't copy very well at all, did it? Whew. Rigid motion. Okay, volunteer to read that for me? Rigid motion. Volunteer to read that for me? Go Go for it, John.
Okay. We're reading rigid motion, right?
Yep.
Okay. The transformation that preserves length and angle measured.
Okay, so here's the deal. If I had a drawing like this, if I had maybe a rectangle in here like this, and I said that this was 6 and 4 on that, and all these angles were right angles, a rigid motion simply means that if you move this, these are all right angles, and they're kind of hard to see. A rigid motion simply means that if I move that somehow, or slide it in this case, since that's the movement we're going to be doing, it means that the shape would stay exactly the same. In other words, the lengths don't change and the angles don't change. So if I slid this over to the right and made this look like the following, whoops. If I made a rectangle like this, over here look like the following. If that was a rigid motion right here, what would this top length have to be? 6. What would this width have to be? 4. That's considered a rigid motion because the angles aren't changing and the lengths aren't changing. That's considered rigid motion. Okay? Guys, and then the last thing that we'll look at is what we call a composition of transformations. Composition of transformations. Basically, it's going to be a combination of 2 or more transformations to form a single transformation. Okay? It just means multiple moves. That's all it means, guys. Okay, so again, just kind of have a general cheat sheet for all the vocab words. I don't expect you to memorize the terms word for word, but when I talk about those terms, I at least want you to have an understanding of what it is we're going to be doing. Okay? Now, can I borrow somebody's notes real quickly? Because my grid certainly didn't show up as well as yours. So can I borrow these, Grace? Thank you. I'm going to get my lines in here as best I can like you do. So I've got to look at this. This did not show up well at all.
Mine didn't show up.
Okay, here's what I'm going to do. Looks to me like you guys should have a line in here yet too. Right? Looks like you should have a line in here. Does that look right to you guys? Just give me a second here. I can fix it. I can fix it. Can't even tell, can you? That looks better, doesn't it? Is that better? Okay, here's what I want you guys to do. Guys, we're going to put a vector up in here, and I'm going to tell you to do this right here. I want you guys to draw a vector in here. And you know what? I think I'll tell you to plot some points first. Let's do this. Let's go right here. Kind of not the very top right, but right in here. Label that point right there. Okay, go ahead and plot that point. Okay, and then from this one here, from that point that you have kind of in the corner there in example 1, I want you to come down 1, 2, 3, 4, 5, 6, and then back to the left 3. So from that point, go down 6 and left 3. Okay, down 6 and left 3. From that point right there. And I really don't care where you start that first point, but as long as the first point you go down 6 and left 3 units, so it looks like I went down 1, 2, 3, 4, 5, 6, and then left 1, 2, 3, right? Okay, here's what I want you to draw for your vector then. Here's what I want to see out of your vector. And just sketch it in there. It doesn't need to be perfect. All right, that's the way I want to see your vector. Your vector starts up top right, and it moves to that bottom left point. And we'll label these points. Let's call this point up here P, and this point Q. Okay, so guys, do we have that drawn first? We can't have that sketched out. So from that top right point, P, you're moving down 6 and left 3. Okay. Label them P and Q. Your job's to name the vectors. Let me ask these questions. What's the initial point right here? What's the initial point? P. What's the terminal point?
Q.
So if the initial point is a start point, P, we would always start your vectors at that point. So the question becomes, what's the name of the vector? What's the name of the vector? So what are you going to label first as your vector? P or Q?
P.
P, because that's where we're starting and we're going to where?
Q.
Q. So there's the name of the vector right there. Now we want to write its component form. And its component form basically is to say, how do you get from point P to point Q? Basically, what's your change in X? What's your horizontal component? What's your change in Y? So think about it. We've got to go horizontally though first, don't we?
Yes.
So what's the horizontal change right here? Watch what I do here. Horizontal change. How far left do you move? 3 units, right? How far down do you move then? 6 units, right? Now, since I'm moving left 3 units on the horizontal, what kind of change, or how am I going to denote that? Is it positive or a negative since you're moving left? Yeah, that horizontal change is -3. And then how far down are you? 6 units down, but since we're moving down, we have to call that what type of 6? So what we're saying right here then is this. You're going to have a grid right here, not necessarily a coordinate plane. And you're going to say, hey, here's a vector right here. How do you write its component form? How is the vector changing? That's all that component form means. How is it changing? From start to finish, how do you change? Well, from start, you would go left 3 and down 6 to get to the end, wouldn't you? Everybody agree with that? Do the horizontal part first and then the vertical part second. So here's what the component form is going to look like. Going to be -3, -6. Okay? Basically just counting from start to finish. How far left or right? How far up or down? Okay? Make sense to you? So if I say, hey, here's a vector, give me its component form, count how far left or right, and then count how far up or down from start to finish. All right? That's pretty easy, isn't it? All agree it's pretty easy? Okay. Everybody have what they need there for that one? All right. Then, example 2 here, translating a figure using a vector. All right? Well, it says it in this right here, you've got a triangle. And it says your vertices are which points, guys?
0 and 3.
Let me roll this up here quickly. Okay, the vertices on my triangle ABC are 0, 3. How do you get to 0, 3, guys? Go up 3. Boom. 1, 2, 3. There it is. That's point A, right? How do you get to B? So I'm going to go right 2 and up 4, which is right 2, up 4, right there. That's B. And where's point C at, guys? Over 1. Okay. Now, do you guys all see the triangle we form right here? If you want to go ahead and sketch that, go ahead and do that.
Oh, now my dotted lines show up. Stinker. Let me fix this quickly. Okay, A to B right here. Boom. B to C, boom. There's a triangle right there. That's the triangle it's formed, ABC. Now, it says translate ABC using the following vector. Okay. What vector are they asking us to use under this translation? What's it say? -1, -2. What do you think this translating a triangle using this vector means? What do you think the -1, -2 means? Okay, so this right here, this -1 is saying take your figure and move it. This is saying move it, whoops. This is saying move it left 1 unit, right? What's this saying right here? Down 2 units, right? That's saying move it down 2 units. So if I do that, here's what you end up with. Take your point A. You always take your vertices and just translate them the way the vector tells you to do it. So this point A is going to move what direction, guys? Left 1 and down how much? 2. So what I'm going to do is I'm going to say this is where point A falls. And what we call this, guys, is the following. We say, hey, this is not A, but actually it's where the image falls. This is going to be called A. I can't see that very well. Yep, and we read that as A prime. We read that as the point A prime right there. Okay? You do the same thing with points B and C, and once you've got those plotted, you simply draw your figure. So B, same thing. Move it left 1 and down how much? And that kind of falls right in the middle of that first triangle, doesn't it? And then C prime, left 1, down 2. All right, so let me label these. This point is my point B prime in here. And this is my point C prime down here. I have a quick question. The question is this. Is this a rigid motion?
Yes.
It should be a rigid motion because, what was the definition of rigid motion? Do we change the size or angles at all?
No.
We just moved it to a different position, right? So it's considered a rigid motion because we didn't change anything. So if I say, hey, plot your original figure, ABC, and then translate it using a certain vector in component form, all this is really telling you to do how far left or right, how far up or down to move it. That's pretty easy, isn't it? That's pretty easy, isn't it? All right, questions so far about those two examples then? Okay, let me zoom back out here. Yeah, I think we're okay. I think we're okay on this. Something doesn't look right to me, but it is. It's just the way it drew there. Okay. All right, let's go to the third page then, kiddos. All right, this one says write a rule for the translation of ABC to A prime, B prime, C prime. Writing a translation rule. Okay, this one's kind of a tricky one. They use kind of a different form, from component form to what we call writing a rule for translation. And this is really the same thing. Let's do this. Let's make it easy on you guys today. Let's plot a right triangle right here. Let's go, oh, I don't know. Let's pick the point -4, 4 here. Plot that. Left 1, up 4. Ah.
4, B,
And then let's go left 4 and up 7. Okay, and we'll draw this triangle. I'll do the best I can. You just do the best you can as well. And I'm going to label this triangle A, B, and C. Okay. And then over here, I want you to draw the following triangle right here. Let's start at 2, 1. Let's go 5, 1. And let's go 2, 4 right here. Draw that triangle as best you can. Any idea how I'm going to label this top point on the black triangle? A prime. What do you think we're going to call the bottom left? B prime, and finally this. Okay. Is that a rigid motion, first of all? Shapes the same? You bet they are. All right, so here's kind of the tricky part. If there is a tricky part, and I don't think any of this is tricky. The other one said write stuff in component form. They're basically saying, how far does it move by the vector? Okay? This is what translating or writing a rule of translation means. Here's the rule for this right here, guys. The rule is going to take all points, x comma y, and it's going to translate them into the following. Okay, this is the rule. You always start out with x comma y for your rule. Okay? My question is this: which of those two triangles is the original one, or the pre-image? The red one or the black one?
Red.
Why the red one?
That's what you started.
Run with it, Faye.
Because it doesn't have the comma after the letters.
So no apostrophe up there, right? Nor I just call them prime marks. Is that okay?
Yeah.
Okay. And I forgot that up top there for the A, didn't I? So I better fix that. So there should be a prime right up here. Okay, so here's the deal, guys. Let me ask this question. To get from A to A prime, let's think about the change in x. What direction do I have to move from A to A prime?
Right.
Right, so am I adding x values or subtracting x values? How much would you add to go from A to A prime?
6.
Looks like 6 units to the right, wouldn't you? To go from A to A prime, it looks like count over 6 units. How far down would you have to go then? Then down 3 here, right? Let's see that down 3. Is that a plus 3 or minus 3?
Minus.
Let me show you what this rule looks like then. This is saying this is your original figure. This x comma y is like your original figure. And to translate that original figure into our image figure, you need to move that 6 units to the right and 3 units down. Now, does 6 units to the right affect x values or y values? 6 units to the right. Okay, if I'm going right, am I adding 6 or subtracting 6? So the way that this comes into play then, to go from your original to an image, you would go ahead and take x and add how much? Well, 6. Take all your x values, add 6. What do you think you're going to do to your y value then to get to A prime? Y minus 3. All this is simply saying is to go from your image to your original shape, which is x comma y, to an image shape. You would basically take your x values of your vertices and add how much? 6. And your original ones, the y values, what would you do to the y values to get there? So let me tell you this. If an original point was, say, maybe, I don't know, 12 comma 18. If an original point was 12 comma 18, under this rule of translation right here, where would the image fall? In other words, this is my x original and this is my y original. So where would it fall under this translation rule? Where would the image point fall? Where would 12, 18 fall under this translation rule, x plus 6, y minus 3? 18 comma 15, right? Because 12 plus 6 is how much?
3.
12 plus 6 is how much? It's been a long week, hasn't it, Brett? 12 plus 6 would be the 18, right? And then 18 minus the 3 would be what here, guys? 15. Okay, 15. Are we good with that, guys? It's basically counting. Left, right, up, down, add, subtract. That's all you're really doing. That's all you're really doing. Okay? So here's the deal. I want you guys to try example 4 on your own. Okay? I want you guys to try example 4 on your own. See what you come up with. It says translating a figure into coordinate plane. First thing you're going to do is you're going to graph your pre-image or your original figure. And then, right here, they give you the rule of translation to be able to graph your image figure. Just real quickly, describe to me, after you get that pre-image graphed, what direction are you going to move it to get the new one? Look at what I've underlined up here. Left, how many units? One, and then up 4. Okay, up 4. So go ahead and try that right there. We'll see if we agree on what you get. Okay, guys, do I have the original figure drawn correctly?
Yeah.
You guys agree with where I put the original? Okay, so what are you going to do with each vertex then, guys, to create the image of it? So every image is going to move left 1 and up how much?
4.
So I'm here. Left 1, up 1, 2, 3, 4. Left 1 and up 1, 2, 3, 4. And left 1 and up 1, 2, 3, 4. Guys, are we looking okay on this?
Yeah.
That's pretty easy, isn't it? So the real whole idea, I guess, do you understand what this rule for translation means right here? Do you understand what this notation means? Basically says your original might be a coordinate, something comma something. To get the image, take the x value and subtract 1. Take the y values and add 4. Okay? And by the way, I'm just going to label 1 point on each of these. I'm going to call this B prime up here, so I know that that's the image, and I'll call this B right there, since I know that that would have been the, I've got that in the wrong spot. That should have been C prime. This was C prime right here, and this was C. And I'll just put those in there so I know what was the original and what the image figure was. Okay? All right, are we good on that page, kiddos?
Yeah.
All right, that said, last one here. Last one. And then I think I assigned like 322 problems over this today. 322 problems you got today, I think. A lot of them.
You're joking.
I like what they
No, I'm not.
Okay, never mind.
It's not April Fool's Day joke.
Okay,
Oh,
now.
I forgot to say
There.
football.
Yeah.
I forgot that as well.
All right. Let's talk about this right here, guys. Performing a composition. What I need to remind you guys is this. Composition is like multiple transformations happening at once. Multiple transformations happening at once. Where are my football players at?
Right part.
Is anybody a punter at all? Okay, so I can pick on him next hour about this. But in football, guys, we talk about the punter. Dylan?
Dylan can kick the ball.
I just had yards, but
It
no, I can
goes higher further than it goes.
I don't know. I think this is.
He's got a
That was
good coefficient. Here's the deal. In football, a punter will punt. If a punter has a 60-yard punt, and then the return guy comes back 15 yards, what's the change, or returns at 15 yards, what's the change in field position? 60-yard punt, return is 15 yards. What's the change in field position? 60 this way, and then this guy's going back up field after 45 yards, right? Okay. Okay. 15 yards positively, not negatively, okay?
My bad.
We're not watching the Vikings here, all right? Okay. All right, so here's the deal. One change right here when I punt might be 60 yards down the field. Ball lands here. And then all of a sudden, the ball goes the opposite direction for 15 yards, right? So we say in football, the net on that was 45 yards, right? You guys have heard that term in football before? Net?
Nope.
Are you kidding me?
I think I've heard it maybe once or twice
Okay.
before.
Well, I would say the net on that was 45 yards because that's the change in field position. Okay. Well, if I'm going 60 to the right here, that's like adding 60, right? And then going to the left 15, that'd be like subtracting 15. But isn't that the same if I go 16 this way and then 15 back? Isn't that the same as starting here and just going 45 one direction and stopping right there?
Yeah.
And they're going to end up in the same place? See what I'm saying there? John?
What do you mean by one direction? Remember the term.
The term. Okay. All right. Don't take things out of context. All right, so here's the deal. It says graph RS with endpoints -8, 5 right here. Watch this right here. So let's do this. We're going to graph this RS, vector RS with endpoints -8, 5. So I think we can kind of get it in. Here's -8, 5 would be just off the screen. So go left about 8 about here and then up 1, 4, 5. -8, 5 is going to be right about here, guys. So go ahead and label that point R. Where's your S value at? -6, what? So here's 1, 2, 3, 4, 5, 6, and then up 8. 1, 2, 3, 4, 5, 6, 7, 8. That puts you clear at the top here, guys. This is your vector RS. Okay, so go ahead and draw that vector like so. Okay. Now, guys, it says graph its image after the composition x. Y turns into x minus 1, y plus 4, and then x plus 4, y minus 6. What I want to get at, guys, is the following. You right here have two translations, okay? And they're basically saying, hey, slide this vector to one spot, and then from there, slide it again. Does that make sense to everybody?
Yeah.
Okay, so the first thing that this is really saying to do, guys, is the following. This x minus 1 is saying go what direction? Left 1, but the second translation then says turn around, go right 4. Well, if you go left 1 and then turn around, go right 4, if you could put that in just one move from the original point, what would be the net, or how would that change? Right 3 units, right? Because if you were on a number line right here, and you started at 0, went back 1, and then right 1, 2, 3, 4, that ends you right here at basically right 3 units, okay? So what I'm going to do here is I'm going to go ahead and take this combination of transitions, or we call it a composition of translations, and I'm just going to write it as one single one. So we're going to write this really as x comma y turns into the following, x plus 3. Now think about this one right here, guys. The y values. Originally you go up how much? 4, and then turn around and go down 6. Well, what's the change overall when you combine those two movements from where you originally were? Down 2 more, right? So really, guys, these two translations put together are a single translation. Add 3 to x, or move right 3. Subtract 2 from y, or move down 2. You okay with that? Okay, so let's do that. Move to the right 3. All right, so there's 1. Here's 1, 2, 3. And then how far down do I have to move? 2. 1, 2. So what coordinate does that land you at right there? Kind of into my work. Well, it looks like -5, 3. Is that right? And then move this one down. I'm sorry, right 3. 1, 2, 3, and then down 2. And it looks like this lands at -3, 6. There it is. So if I give you multiple translations, and I say, hey, you need to move stuff, do you understand how multiple translations could be rewritten as one single rule of translation? You okay with that? Keep the x's together, keep the y's together. All right, so last problem here real quickly. Last problem says another graphic artist is designing an alternate icon for something. It doesn't make any difference. Doesn't make any difference. It says she moves the red rectangle 3 units what direction first? 3 units to what direction? And then 1 unit down. Then she comes back and says, you know what, I don't like that. So let's move that now 1 unit to the left and 4 units up. Okay? It says rewrite this composition as a single transformation. So here's the deal. We're going to write a rule for the translation. Guys, talk to me about the overall change in x right here. Where am I going first? What direction were you going first? 3 to the right, and then you turned around and went 1 left. So overall, where did you end? 2 to the right, didn't you? So what should I put right here when I end up 2 to the right? X plus 2. And now think about your y values, kids. It said she moved 1 unit down and then turned around and moved 4 units up. So how about the overall change, or the net there, if you will? 3 units up. So what should go after x plus 2? Y plus 3. Guys, that's all about translations. That's how you go ahead and you write stuff in component form once you have a vector. That's how you write rules for translations. You're simply sliding stuff left, right, up, down, whatever it might be. Okay? Questions about this at all? Again, only 4 sections in this chapter. This one's pretty easy. The others are going to get a little trickier, I promise you that. But on top of that, I think you should do pretty well with this. Sent the assignment out. It won't be due until Tuesday. Remember, when's your makeup day for retake on the test, if you want? April 8th. Okay, April 8th. Questions at all, kids? All right, you guys have a great